Hello, good evening everyone. Today we are going to talk a topic on digital design and computer organization. Here is the lab program 6. Design Warlock program to implement different types of multiplexer like tools. Yeah, today we are going to talk a topic on multiplexer. Multiplexer is a combination circuit which has two n power inputs, lines and a single output line. It is a multi-input and single output combinational circuit which the binary information is received from the input lines and directed to the output line. On the basis of these selection lines, one of these data inputs will be output connected to the output. Unlike the selection lines will be in the power of n, and input lines will be 2 to the power of n lines, and the total number of possible will be the combination. Will be 2 to the power of n will be the combination of inputs. Multiplexer can also be treated as mux. Now we shall discuss the Warlog HDL program on 2:1 mux. Here the Warlog HDL program for 2:1 mux. Here the module name. Here the 2:1 muxing having one selected lines and two input lines and one output lines. Here the module represents mux, given name as mux, as selected line as well as data line and output y. Here input is 0:0 s is a 2 bits data inputs based on the selection of s, and output and input 1:0 is the data line connection, and output y will be the results, and the register which stores the output value. Always at condition should be the logical should be triggered when there is a change in the selection input. When there is a change in the selection input y, always at condition uses of selected lines as well as data line, using the case as s and 1. When the s value will be 0, then y equals d of 0. When the value input value will be 1, s value will be the y is equals to d is to 1, and in case, and here the module ends, and the output will be given as that s of 0 is to 0 and d of 1 is to 0 will be given, and the output will be 0. In other words, the output y is equals to 0 is assigned to the data 1. Now we are treating with the Warlog HDL program for 4:1 mux. Here is consisting of 4 inputs and 2 selected lines, that is S2 as well as S0 and S1. And the module HDL program for 4:1 mux would be module mux of selected lines as well as data and y. Input 1:0 is a 2-bit selector input which determines the 4 input data which is selected, and input 3:0 d data. It is a 4-bit input. It represents the possible value that can be selected based on the selection of the input values, and here the output y will be 0. Here register y represents the declaration of the register from y which is used to store the output value, and always at s or d statement holds that specifies the logic insertion should be triggered whenever there is a change in either the selection of selected lines or the input of s or d. And the case yes, here it should be, it initiates the based on the statement based on the selection of input values. If s equals 0, then y equals d of 0. If s equals 1, then y equals d of 1. If s equals 2 is to y. If 2 equals y equals d of 2. If s equals 3, then y equals d of 3. And here end case, and here end module. And for this the output will be, if s equals 1 is to 0 and d equals 100 if s of 1 is to 0 and d of 3 is to 0, and the value of s of 1 is to 0 will be given as 1 1, and if d of 3 is to 0 will be given as 1 1 0 0, and the output y will be 1. Now we shall study the next of 8 is to 1 overlog HDL program. Here the 8 is to 1 multiplexer having the inputs of given 7, and the selector lines will be 3, and output y equals y. Here the module mux is given as the data as well as y, and here input to 2 is to 0. S indicates that connection of 3 select lines and 8 input lines, and the input to 7 is to 0. Here module mux d of y indicates that connection of 3 lines and 8 inputs line. Here input to 2 is to 0. S indicates that 3-bit selectors where I is dependent on values. Here input 7 is to 0 data. It is an 8-bit data which represents the possible outcome value selected on based on selected lines. Here output y, and register y represents declares the register y to use the output to store the register use y user to store the output value. Here always at s or d indicates that it specifies the logic statement. Insert should be triggered whenever there is a change in either the selection of input lines or input lines of selected lines or data lines. Here case s represents it initiates the based on carrier statement based on the selection of the input value as well as the data line. Here case s represent initiate based on the statement of the selection lines. If s equals 0, then y equals d naught of 0. If s equals 1, then y equals d naught of 1. If s equals 2, then y equals d naught of 2. Same as it is, the given numbers inputs the value of y equals d naught 3. Here if s equals 4, then y equals d naught 4. If s equals 5, then y equals d naught 5. If s equals 6 and y equals d naught 6. If s equals 7, then y equals d naught 7. Here the program is being ended, end cases, and to terminate this using the module end module. And here then the output will be if s of 2 is to 0 and d of 7 is to 0, values which are being given as 111, and here for giving as 7 is to 0, inputs are 0 1 1 0 1 0 1 0, and the output y will be 0. That's all.